Okay, in my last video I did a preview of the law of sines and the law of cosines. I went over some formulas, went over the formulas for the law of sines and the law of cosines. Now this video here is going to deal strictly with the law of sines, so let's look at the statement for that. It says for a triangle with angles capital A, B, and C and opposite sides little a, little b, little c respectively, we have the following. The sine of A over little a is equal to the sine of b over little b equals to the sine of c over c. Okay, that's for any triangle. And I mentioned then that the law of sines and the law of cosines basically is used for oblique triangles. That is, triangles that do not have a right angle. Some of the things that you use for right triangles do not apply to oblique triangles. For example, the Pythagorean theorem, which applies for right triangles, will not apply to a triangle that's oblique. Now, the law of sines and the law of cosines will work on any triangle, whether it's right or not, but normally you use them for triangles that are oblique. I also went over this file here for oblique triangles. You had case 1, basically where you were given two angles and a side. It could be denoted by side angle angle or angle side angle. And I mentioned then that this was pretty straightforward. And case 2, where you're given two sides and the angle opposite one of the sides, that's the case that can lead to either no triangle, one triangle, or two triangles. In this particular video, I'm going to deal with the first case where you're given the two angles. Now, if you want some more information, please refer to that particular video. Just click at the bottom on the name for the channel and you'll see all the videos. Again, it was titled The Law of Sines and Cosines parentheses preview. So in this particular problem, they solve the triangle and we're given two angles and a side. So again, remember that solving a triangle, you'll be given certain parts of the triangle, and when they ask you to solve it, they simply mean find the missing parts. So find whatever angles are not given, the measure of those angles, or find the lengths of the sides that are not given. So in this case, you're given two of the angles, so recall that if you have a triangle, the sum of the angles has to add up to 180. So because of that, then we know that angle B has to equal to 180 minus 14 plus 23. And these are in degrees. I'm leaving the degrees out just for convenience, but that's 180 degrees minus 37 degrees basic is what we have here. So this tells me then that angle B is 143. And I'll put the degrees on this one. Okay. So we got angle B then is 143. Okay, now here's where I'm going to use the law of sines. Okay, so remember, it's the sine of the angle over the length of the opposite side, or it could be reversed, as I mentioned in the last video. So I'm going to write it the other way. I want to find side B, so basically then I can say B then, side B then divided by the sine of the angle opposite B, little b, which of course is angle B. So this will be 143 is degrees. And that should equal, according to the law of sines, to any other side. Well, we're given 3. Little a is 3, divided by the sine of the angle opposite that. Okay, so in this case it's 14 degrees. So this would tell me then that it'll be then should equal 2. And then you just use your calculator here. So it's going to be 3 divided by the sine of 14 multiplied by the sine of 143. 3 divided by the sine of 14 and then multiplied by the sine of 143. So use your calculator, and obviously the answers here are given in degrees, so I always want to check what your calculator is set to. So this one is set to degrees, so I'm okay. And then I'm just going to say it's going to be 3 divided by the sine of 14. Close parentheses. So I'm doing this side first. 3 divided by the sine of 14 is that. And then I want to multiply that by, to solve for b, I got to multiply it by the denominator of this over here, sine of 143. So this will be times the sine of 143. And I don't need to put degrees here because my calculator is set to degrees, so the calculator knows this is in degrees. Okay. So I get little b then, the 2 decimal places is 7.46. So I come back over here, and this will be 7.46. Now we're just missing one part of the triangle. So that is C. So little c. So it'll be according to the law of sines. And little c then divided by the sine of the angle opposite little c, which of course is capital C, and this is 23 degrees. 23 degrees. And that should equal to any other side, and I'm going to use the same ratio that I said I had over here. So I'm going to say this will be equal to 3 divided by the sine of 14 degrees. So to solve this, use your calculator. It'll be 3 divided by the sine of 14 and then multiplied by the sine of 23, and that'll give you little c. Okay, so let's clear the calculator over here. Again, 3 divided by the sine of 14, enter, and then multiply that by the sine of 23 times sine of 23. And I get 2 places rounded out 4.85. Okay, so little c is equal to 4.85. And that's the missing part. Okay. This particular type of problem is pretty straightforward compared to the second case I'll be looking at in the next video. You're given the 2 angles, so it's easy to find the third angle. Simply add the 2 angles and subtract from 180. And we got B was 143. And then to find the missing sides, okay, you were given 1 side, so there's 2 missing. We say then B should be B divided by the sine of the opposite angle which is 143, should equal to any other side. We select the given side 3, divided by the sine of the opposite angle, which is 14 degrees. Set up this equation. Divide here, multiply by the sine of 143, so we get b is equal to 7.46. In the same way, little c divided by the sine of the opposite angle, 23, should equal to any other side. We pick 3 because that's given, divided by the sine of the opposite angle, which is 14 degrees. So 3 divided by the sine of 14 degrees times the sine of 23 degrees gives us little c to be 4.85, the two places. Now in the next video I'll be looking at the what is called the ambiguous case of the law of sines. And that's the case where you're given two sides and the angle opposite one of those sides. And in that scenario you can have either 0, 1, or two triangles. Again, if you want to look at the previous video on this, which was a preview of law of sines and cosines, just click on the channel name and you'll see the list of all the videos that I've published so far. And while you're at it, maybe you can subscribe to my channel. And I hope this helps, and we'll see you in the next video.